Hello and welcome to EELE 261 Introduction to Logic Circuits. My name is Brock Lemires and I will be your instructor for this fully online summer course. The purpose of this video is to give you an orientation to the course and talk about the material that we're going to cover, why it's important, and the logistics of how you're actually engaged in the course. The goal of this video is that after you complete it, you will be able to engage in the course, understand what activities that you need to do, what assignments are going to be graded, how much they're worth, and when everything is due. I'll also give you an introduction to myself because I will be the instructor and also the voice and hands that you see in the videos, in addition to the author of the textbook that you'll be reading. Okay, so let's begin by looking at what this course actually covers. So the name of this course is called Introduction to Logic Circuits. A logic circuit is also the same thing as saying a digital circuit, and digital circuits are the building blocks of modern computers. And so the term logic or digital means that the circuit is built to operate on inputs that can take on only one of two values. And that's what makes it logic. So it's like on or off, true or false, or also ones and zeros. And these circuits take in ones and zeros and they produce outputs that are ones and zeros. And it turns out that a circuit that operates on ones and zeros is very simple, and that's true. But if you put a lot of them together, you can actually create very complex systems. And so you've probably heard of people say, oh, computers operate on binary numbers. That's what we're talking about. The ones and zeros are called binary numbers. And that's what we're actually going to learn about. Now, this course focuses on computer hardware. So we are not, while a computer does consist of hardware and software, we are not looking at software in this class. We are only looking at the circuit level of a computer or the hardware. We're not going to be programming in C or Python or anything like that. We are going to actually learn about these very simple logic circuits, so things like AND gates, OR gates, exclusive OR gates, putting them together to create things called combinational logic circuits, sequential logic circuits, and building things like state machines. And we will then learn the theory of those things, and then what we're going to do is we're going to actually build the circuits. So you're going to have a lab component to this class where you'll actually be given these parts, and you'll put them together and actually build circuits that can operate on ones and zeros. And we'll put the ones and zeros into the computer or into our circuits using like switches, and then we'll look at the outputs using like little LEDs, and it'll be really cool. But this course is all about very low-level hardware. Now, at the end of this course, you won't know exactly how a computer works yet, but it does start the path to understanding how to build a full computer. The follow-on course to this, or the follow-on course, is called Logic Design, and that's where we actually look at how you actually build a full computer. So the course is broken into 7 modules. And if you look at the textbook actually has 13 chapters into it. And so a module is the same thing as a chapter, except a module encompasses, assignments and labs and quizzes and stuff like that. But if you look at this class, 261, we will be covering chapters 1 through 7 in the book. And I talked about the logic design class, which is the follow-on. That class actually covers chapters 8 through 13. So if you kind of wonder where you're going with this class, go ahead and look later in the book. Look at chapter 13, and you'll actually see the type of information that you will understand if you continue along this course sequence. So let's look at the 7 modules we'll be covering. The first one is just a very introductory module called Analog versus Digital. And it's to try to start explaining like what is the difference between an analog signal and a digital signal. What is a digital circuit? What is a logic circuit? So just to try to start making that differentiation. Module 2, we look at number systems. And so if we're going to build circuits that operate on ones and zeros, we have to start converting between the way our brain thinks about numbers, which is what we call decimal or base 10, and how computers operate, which is binary or using ones and zeros. And so we look at how you form a number, how you convert between bases, and then we start looking at how you use binary numbers to represent things like positive numbers and even negative numbers. And then in Module 3, we actually start looking at the circuit level, the circuits themselves. So this is where we actually say, okay, an AND gate is this thing that operates on ones and zeros, and here's how it works, but it's also a circuit, okay? So it actually needs power, it actually needs ground, it has inputs and outputs, and it comes in little devices or little parts that we can actually purchase and put down on a breadboard. And so we look at actually turning these things on and seeing how they operate. Module 4 is called Combinational Logic Design. This is where we take those basic gates that we learned about in Module 3 and we put them together to form more complex circuits. So we can say for any set of inputs of ones and zeros, it can produce an output that is a 1 and a 0. And if we start with, the description of what the inputs are and what the desired output is, we can actually go back and do what we call synthesize or design the circuit for that. And you'll learn how to do that design technique. Then we move into Module 5, which is where we get to a point really quickly where the digital circuits get so big you can't do it by pen and paper anymore. So it's just there's too much going on. And it's because as you add more and more what we call bits to a number, or ones and zeros to a number, it's basically an exponential. And so what happens is that it just gets so big so quick that we have to use a different design approach. So in Module 5, we introduced the modern digital design flow, which is using what we call a hardware description language, or an HDL. We will learn about one particular language called VHDL, and this is where we actually type out a description of the logic circuit that we want, and then since we're typing it out into a computer, we can actually perform simulations on our description to make sure it's what we wanted, and then we can actually allow the tool to synthesize basically a schematic that we can then download onto a programmable logic device. And so you'll get experience with the modern digital design flow where we describe these combinational logic circuits, and then we allow the tool to actually create the circuit for us, and then we can test it using a programmable logic device that we hook to our breadboard. Module 6 is where we look at what we call medium scale integrated circuit logic, which just represents some very common building blocks that are based on combinational logics, things like multiplexers, demultiplexers, decoders, things like that are very, very common. And they're so common that we actually say, okay, since everybody's using these, we'll just kind of give them a name and give them a functional description, and you can actually buy chips that actually implement these things. Module 7 wraps up the course, and this is where we look at sequential logic. Sequential logic means that you have the notion of storage. So you can actually store a 1 and a 0. And when you can store things, then you can actually look back in time and say, what was the past value of this? And so sequential logic is where you have outputs of a circuit that depend not only on the current value of the inputs, but prior values of the inputs. And that allows us to build a very powerful type of digital circuit, which is called the finite state machine. Okay, so before we look at the logistics of the course, let me give you a little background on myself, because it's always good to know who's teaching the class and what their background is. It actually has been shown to kind of help you learn the material when you know that the instructor is very interested in the material. So this is my website, and I'll just kind of start here just to show a few things about me. But anyway, I got my degree from Montana State University back in the 90s, and I went to work for Hewlett Packard after that in Colorado. And I was a digital hardware designer in Colorado Springs. And I worked on products that were basically electronic test equipment, so acquisition systems for the semiconductor industry. So our customers were people like Intel or AMD or IBM, who were building next generation computers, and they needed ways to test all of the digital signals that come out of the microprocessor chip when they got their first silicon back and were trying to boot it up for the first time. So I spent 8 years doing that, where I was just designing digital systems. So I was designing printed circuit boards and laying down digital parts, and actually doing programmable logic device design and cables that could carry digital systems, digital signals, and everything to do with digital, basically digital circuits and computer engineering. So that was my prior life before becoming a professor. In 2006, about 15 years ago, I became a professor at Montana State University. And one of the things that happened while I was at Hewlett Packard was that they'll pay for you to go back and get your graduate degree. So I started right away and got my master's degree at the Colorado Springs branch of University of Colorado. Then I went up and actually got my PhD at the main branch in Boulder. And I worked the whole time when I did that. So after I got done with my PhD, I was then qualified to become a professor, and an opening occurred at Montana State, and so I jumped at that opportunity. And 15 years later, here I am. And what I do at Montana State is I teach classes in computer engineering, and I conduct research in computer engineering, and I also conduct educational research on how best to teach computer engineering. So I kind of do all three of these things. And on my website, you'll see that I've written some books that are used in these classes. So you'll see that you have your Introduction to Logic Circuits and Logic Design with VHDL. I also wrote a book using the other language that's used for hardware description languages called Verilog. A couple quick start guides to both. And then also an embedded systems design book, which looks at like how you design microcontrollers. My research at Montana State has been focused recently on building new types of computers for aerospace applications. And so the whole idea is if you can design digital circuitry that you can put on a programmable logic device, why not take advantage of the ability to change that circuitry in real time? And so what you're seeing here, this is just a little representation of a programmable logic device where I have different circuits on there that I can swap in and out. So it's like, okay, it's an adder, no, and now it's a subtractor. But if you can do that, it turns out that these modern programmable devices are so powerful, you can put in full-blown computers. So you can think about it where it's like, oh, it's a Windows computer. And then it's like, no, it's a Mac. And then it's like, no, it's a Linux. And so you can actually change the type of computers. And we figured out that by swapping in and out the hardware, it actually will flush out faults due to radiation in space. And so for the past 15 years, I've been working on building this new type of computer system based on reconfiguring the hardware in real time, which is potentially more radiation tolerant than existing flight computers. And this has allowed us to do a whole bunch of cool things in my research lab that involve building this computer and flying it. And so let me scroll to the bottom here. So it kind of all started, we've done things like we build the computer and we've flown it on sounding rockets where they just go up and come back down. You can see here, this is like what it looks like. It's about the size of a Rubik's Cube. You can see we bolted it to a rocket and shot it up into space. We did another one. You can see here, I'm out at NASA Wallops Flight Facility with one of my students right here. This is kind of what another version of it looked like. We actually put this computer on the International Space Station. So you can see here's the MSU logo as it's being installed on the space station. Again, size of about a Rubik's Cube. We had the opportunity to build some satellites. So there's actually 2 satellites in orbit. This thing right here is about the size of a loaf of bread. You can see the M logo for Montana State. And here it is coming out of the space station. So there's the M, gets put into orbit. That thing's circling Earth right now. We've done high altitude balloon tests. These balloons are massive. They're the size of a building. I don't know if you can see it, but down here, this is like a semi truck. So that's the size of these balloons, and they can go up to 100,000 feet and hover for potentially up to months. So here's another test of the computer right here. Another satellite, you can see the cat head for MSU, and here it is coming out of the space station again. Here's me and my students out here watching the rocket go up. And then the big project we're working on right now is we actually got selected to go to the moon as part of the Artemis program. So we're going to be demonstrating this computer that's been developed in my lab on the surface of the moon on a commercial unmanned lander. And so we're going to fly in 2023. We'll be heading up there, and they'll hopefully land, softly, and then we'll operate on the surface of the moon to test this new type of computer. I bring all this up just because, like, if I go back to my main page, the reason that I bring this up is because logic circuits, digital circuits, embedded systems, like this is what I am passionate about, right? So it's like, this is what I chose to study in school. This is what I did when I worked in industry. This is what I do research on. This is what I write books on. This is the classes that I teach. So this is really what I'm passionate about and what I have a background in. And so I don't know, I just tell you that because this stuff is awesome, and I'm very excited that you've chosen to learn about it. If you're interested in some of the more recent news stories about me, you can go out to my webpage, and I just kind of put little news articles on here as they come out over time, and you can kind of see all these cheesy pictures of me doing all this cool stuff. But anyway, that is me, and that's the background on your instructor. Okay, so now let's look at the logistics of the course and how you actually get started with the activities. So everything in the course is handled through what we call Brightspace. Brightspace is our course management system. So if you go to ecat.montana.edu, what it'll do is it'll bring you to the login page for Montana State University's Brightspace system. And you'll be logged into here, and what'll happen is that you'll see your classes that are active listed over here. And you'll see like announcements for all your classes. So if you come over here, you're going to be looking for this Intro to Logic Circuits. And when you click on it, you'll be brought to the main page of the course. And what you'll see on the main course is the announcements. Okay, so I have a little announcement right here just to kind of show you that you're in the right place and what you're kind of start with. And I tell you basically first you're going to just go to the syllabus and orientation page. Up across the top, you're going to see all the tools for the class. And so you'll see content, grades, quizzes, etc. Everything is linked in content. So you're really only going to click on two things ever. It's really content and grades. There are things like quizzes and assignments that you'll upload stuff to, but I link them all within the content pages. So if you come down and look at the content, what you'll see is I have a page for all of the different areas that we're going to go. So there's a page for every module, there's a page for the final exam, and then there's a page for the course information and syllabus. So if you start off with course information and syllabus, I give you like kind of a highlight of the syllabus right here, but I put it in electronic form because it has the links to things like, oh, here's our email, here's our WebEx room, etc., etc. So when you start off, the first thing you want to do is the syllabus. So you want to click on the course syllabus. This is where you find it right here. And this right here is, here it is, the syllabus, okay? And so this is basically everything, the specifics of the course, and this is it. Okay, so let me go back here and I'll kind of give you an overview of who's who, and then we'll go through the syllabus and look at the specifics of it. So first of all, here's my contact information. I'm in 316C Norm Asby Ornson Hall, email, phone, etc. My website right there. More importantly, though, is we're going to use WebEx. We're going to use email as our primary form of communication, but when we need to talk kind of, I guess, in video form to do like help with homework or something like that, we're going to use WebEx. And so I have a WebEx room that will always use this link. So we'll just email, set up a time, and then we just use this link and we both jump on there. You'll probably do that a lot more with our teaching assistant, who is Charlie Kinneberg, and he is going to have his own WebEx room. Here's his email, and he's who you ask questions for on basically everything. So if you have questions on your homework, questions on your lab, you need help with your lab, he's who's going to help you. He's also who's going to be grading everything, so you want to be in touch with him the most, because if something's wrong with your grade or you lost points for something, he's who you're going to actually email. Within here, you see the syllabus, obviously the course overview video, that's what you're watching right now. But also the first assignment is the course overview quiz, and I'll show you how this fits in to the schedule when we look at the syllabus. For this course, I'm going to show you the 4 main items that you need. First and foremost, you need a computer that runs Windows. Okay, we're going to use design software, and it doesn't run on a Mac. So if you have a Mac, you either got to drop the course or you got to find a real computer to use, something with Windows. Okay, so I'm sorry, that's just the reality of engineering. If you're going to be an engineer, you got to get rid of your Mac. Okay. Or you got to figure out how to dual boot it, or you got to figure out how to get access to a computer. If you're in Bozeman, you can use the Windows computers in the lab here in Cobley Hall, so you can come over and use those. So if you are stuck with a Mac, you don't have to drop the class, you can use ours. But if you're not in Bozeman and you can't find a Windows machine, time to drop. Okay, second thing you need is the textbook. It's a second version. I would buy it through Amazon. Amazon always has the lowest prices over anything, and always beats the bookstore, etc. So if you click on that, it'll take you out to the link. If you're a college student, you get free shipping and all that sort of stuff. The third thing, this is a big deal. Digital Logic Portable Kit. All the labs are going to be done with this kit that you checked out. And so I've already emailed everybody and asked you to come by and pick up your kit. If you are watching this video and you don't have your kit, you should take action. Okay, you can pick your kit up in the ECE office in Cobley Hall, or if you're not in Bozeman, email me immediately and tell me your address and I will ship it to you. You have an assignment due the first week of class, so you need to get going right away. You need this. You cannot make progress in this class without the lab kit. All the learning for the class is done using the lab. Okay, so you're going to see that the homework isn't really worth that much. Quizzes really aren't worth that much. The lab is where all the learning happens, and so that's the most important part of the class. You do need a camera capable of taking short videos because that's how we're going to do our lab demos. So you're going to build a circuit, and you're going to actually just take a little video of it showing the circuit in operation, so showing the inputs moving and the outputs moving. And then you'll upload that video along with some other things like maybe pictures of your design, pictures of your breadboard, screenshots of a simulation. And that's how you're going to actually demo all your labs. And then Charlie will go in and he'll look at them. And it's remarkable how easy it is to see if your circuit's working in a video, because we're so used to seeing it that we know what to expect. So even a 5-second video, we can see that your circuit is working. So that's how we actually handle the lab part of this. It's with a digital logic portable kit and a camera. Okay. So now let's go and look at the syllabus and see how that maps back to all of the course, okay? So when you come in here, let me zoom in here a little bit. So course intro, we already talked about it. Outcomes, everything we do is to achieve a learning outcome. So you can look at these learning outcomes and figure out like, what are you specifically gonna do? Contact information. The course runs for 12 weeks during the 2021 summer. And we have weekly deadlines that you'll see. But if you want to work ahead, you can. Okay, so this is kind of this is an asynchronous, quasi-asynchronous, meaning that you have deadlines each week. I give you stuff to do each week, but it's up to you when you want to do it. Okay, I suggest not doing it all at once, like trying to do it at one day. You should break up the content over maybe like 4 to 5 days and only spend like a couple hours each time. In general, this class is going to take you about 8 to 10 hours a week. And so try to plan accordingly. It's way better if you just break that up into a couple hours a day. All right. Same information we just looked at with the camera. Course website, we're on it. Office hours, just email and we set something up. Okay. So this is really asynchronous. There's no time when we're sitting around here. Just make an appointment. Here's the way that homework or the grading works. Okay. There's 1,000 points possible in the class. 250 points or 25% is your homework. So every section in the book will have a little homework assignment, okay? Labs are worth 45%. So you can see that the labs are the big one, okay? So that's like almost half the grade is your labs. You're gonna have end module quizzes. There's obviously 7 of them because we have 7 modules, and those are worth 200 points, 20%. And these are kind of supposed to represent like what it would be like to have an in-class exam, except there's 7 of them, so they're not like major exams. So you have, it's not as high stakes. But these are kind of your exams, and I'll show you the form of them once we get down here. And then a final exam worth 10% of your grade or 100 points. Your letter grades are basically, I grade straight. 90 is a A. I don't believe in the minus system because you can't have an A plus, right? So you can have a 90% and that's an A minus, but if you have a 99%, you don't get an A plus. So I think that the minuses are a little unfair. But I have to reserve the right to give a plus or minus if I want. You have to pass the lab. So the labs are most important. So you have to have a 70% of this portion of your class in order to pass the class. And everything, you have to build your own circuit. So obviously in engineering, we work together, we collaborate. But if you're working in a group where, there's 3 of you, let's say for example, and you're all live, you can't all use the same circuit and turn it in. So everybody has to build their own circuit because that's where the learning comes out. Academic policies, so that feeds right into academic policies. We absolutely collaborate. Engineering cannot be done alone anymore. However, the difference between collaborating and cheating is where you turn in somebody else's work. So you you take a picture of their circuit running or a video of their circuit, or you look at their screen and copy their multiple choice answers into yours. Collaborating is where you're working together. So you're trying to how did you get this circuit to work? Can I see your work? What's wrong with my work? And you both build your circuits independently, but collaboratively. So that's kind of the difference between the two. Here's the activities of the course. Basically, every time you come up to a new little section, you're going to have a reading assignment out of the textbook. We're going to check, covers chapters 1 through 7, page by page. Every section of the book in chapters 1 through 7 we're going to cover. Okay, so we do that and you read it. There's also instructional videos. So I designed the course first, then I wrote the book to match the course, then I recorded videos that match the book. And so you have instructional videos. The videos and the reading are covering the same content. So some people like to read, some people like videos, some people like both. And so I give you everything, okay? So after you do that, that's kind of your content delivery. That's how the new material gets into your brain. Then what you're going to do is you will have a homework assignment for every single section, okay? And then after a couple sections are put together and you have enough information to build a circuit, you will then have a laboratory, okay, or lab exercise. And so you'll actually build something. Then at the end of each module, you'll have a quiz, okay? Let's talk for a second about homework versus quizzes, or end of module quizzes. Your homework is going to be, a lot of the homework are going to be multiple choice quizzes. The difference between a homework and a homework quiz and a end of module quiz is that the homework quiz is open right now and it goes away when it's due. Okay, so you're going to have deadlines every week and you can work on the homework up until the deadline. So you can open the quiz, you can work on it, you can save it, go away, and you can chip away at it until the deadline. Okay. End of module quizzes are supposed to emulate kind of tests, right? And so you only have a certain amount of time. So once you start the quiz, you only have a certain number of minutes before it goes away. So they're either going to be 30 minutes long, 60 minutes long, or 90 minutes long. And so you got to make sure that when you're ready to do the end of module quiz, you sit down at the computer uninterrupted, hit go, and then complete it. Because you can't start the quiz and then log out 10 minutes later and come back. The clock runs regardless of whether you're logged in or logged out. So that's the big difference. Then at the end, we're going to have a comprehensive online exam, final exam, and you'll get 3 hours to do that. And we'll do that during the last week of this semester. Okay, your homework is going to consist of mostly multiple choice quizzes, but we're also going to have some simulations once we get to the module 5 and 6 and 7 where we're using VHDL. So you'll actually type in a functional description and simulate it, and then you'll upload like screenshots in your source code. This is the big table right here. Okay, so this table is what you should reference every time you sit down to do something for the course. This has the weekly schedule every single week, 1 through 12, and it has what we're going to be covering for that week, and I break it out every single section, whether it's a lab, you do have a lab, whether you have a quiz, and I tell you the point value and the due date. Every deadline is due on Wednesday at noon, typically of the following week. The first week, I got to make sure that you engage in the course quickly. So what I have is the course starts on Monday, May 10th. The first deadline is Wednesday, the 12th at noon. And so I have you do a couple of these assignments and a lab, and that is just to make sure that you actually are logged into the system, understand where everything is, and have your lab kit. The lab 1.1, all you're doing is installing the software for all the equipment, and basically you just hook it up and show that it runs. So it's a very simple lab, but the key to it is you can't do it unless you have the equipment. Okay. Same thing with sections 1.1 and 1.2. They're very short. Like chapter 1 is like 2 pages, I think, long. So it's just to make sure that you can read the book, find the videos, and actually log in and do the quizzes. They're not worth many points, but again, it's just to make sure that you engage. In addition, the first thing you're going to do is take this course logistics online environment quiz worth 1 point. And that's, again, it's just going to ask you questions about, do you know where Brightspace is? Do you know that you need a portable logic kit? Nothing to trick you. It's just to make sure that you're engaged in the class. Okay, that's going to happen the first part of the first week. And then we have module 2, and this is where we get into the flow. So module 2 is on number systems, and you'll notice that it's due the following Wednesday at noon. Then you go to week 2, you'll notice that here's all the stuff we're going to do. Again, it's homeworks, it's a lab, it's a quiz. They're due the following Wednesday at noon. You go to week 3, here's the activities. Some homeworks in a lab, they're due the following Wednesday at noon. Same thing here, following Wednesday at noon, following Wednesday at noon, following Wednesday at noon. So you're gonna get in this flow where you're working on something for the week and you know that everything is due the following Wednesday at noon. And then it's up to you to determine the pace at which you work. But again, I give you that flexibility, but I want you to try to avoid doing everything at one time for the whole week. That's the worst way to learn the material. So I don't try to say like, I'm gonna do this class Sunday. It's like, no. Do it, break it up, do a couple hours every single day. That's where you're gonna get the most bang for your buck out of this class. We just march along, and at the end, you'll see that there's a final exam. This is the only deadline that's on a Friday because that's the end of the course, so I give you a few extra days to do that, and you're done. You can see it all adds up to 1,000 points. Here's the homeworks, 250, the labs are 450, quizzes are 200, and the final is 100. And then you'll notice that some of these are marked with an asterisk, double asterisk. And that means that instead of being multiple choice quizzes in Brightspace, they're actually simulations. So notice that this one right here, this is a homework assignment. It's worth quite a bit. And that's because you're actually going to type out some VHDL for a functional description of a circuit, and then you're going to simulate it and upload the screenshots for that. So you get more points because it's a little bit more involved. Same thing here. You got a double asterisk. That's going to be a simulation. Then you get down here, look at module 6. You got this stuff right here. Look at these labs right here. These ones are actually on the using VHDL and the programmable logic device right here. And you'll notice that these guys right here get really fun. Discrete, I'd mark these labs as discrete, some of them. That just means you're using the little individual parts that come in your kit as opposed to putting stuff on a programmable logic device. Okay, so that is the flow. Again, like I say, every time you log into the class, you're going to look at this first and then figure out what you're supposed to be working on that week, what's graded, what the deadline is, and kind of get a feel for what you're actually working on. And then if you come back to the course, so let me get back to the course. I'm going to come back to the main page of the course, and I come up here, I'm going to go to content. Let's take a look at how you access the course material. So if I come to module 1, this is a representation of what everyone looks like. Module 1, analog digital. I start everything out by telling you the learning outcomes for the module. So in this one, it's describe the fundamental difference between analog and digital, blah, blah, blah. Then you get into the activities. And so here's what these activities look like. For every section, I have a reading assignment in the textbook, I have an associated video, and then I have a homework assignment. And then look at section 1.2, read, watch a video, do the homework. After a couple sections worth, you go in to do a lab. So now you have to read the lab description, watch the overview video, and do the lab, and you upload it to this folder right here. After that, you take the end of module quiz. If I go to the next module, you'll notice that the flow is the same. It's just that some modules are longer than other ones. So for example, learning outcomes, section 1, read, watch a video, do the quiz. Section 2.2, read, watch some video, watch some video, watch some video. There's 3 videos here. Do the homework. Section 2.3, read, watch, do. Then you read, watch, do. And then after 4 of them, you're at the point where you can do a lab. So then you read the lab description for 2.1, and I actually give you overview videos for the labs too. Upload your deliverables here, take the end of module quiz. Let's take a look at what some of this might look like. If I read this thing and then I click on the video, it's going to take you to a YouTube video. Okay, and so here I am. This is just me, writing on paper. Basically, that's what these look like. This is like the equivalent of you watching me write on a whiteboard if we were live in class. But as we go through the class, you'll start seeing me do more stuff with like typing out code and stuff like that. So that's what the videos look like. What does a homework look like? If you come in here and you click on one of these, this is now a multiple choice quiz. So I'll preview this so it kind of is similar to what you see. Since I'm logged in as the instructor, it's a little bit different. Okay, so multiple choice quiz. What is the radix of a binary number system? Oh, I just do that. And notice this is a homework. I can come down here and I can submit it, or I can make sure it's saved, 1 of 9 saved, and I can exit. So that's all the homeworks look like. Let's take a look at what a lab might look like. So I come over here and I say labs 2.1, and I have this big PDF that has all of your lab exercises in it. Now, you only have to download this once, but if I come out here and I go to lab 2.1, I'll come down here. And should have done something different than that. Okay, here is the lab. So it gives you the objective, learning outcomes, the parts that you need. These are all on your lab kit. And it tells you, more importantly, what you're going to deliver. So you got to know, you're going to do the lab, but what do you actually turn in to get graded? So you're going to demonstrate the use of the arbitrary waveform generator, blah, 50% of your grade. Produce a logic analyzer measurement, 50% of the grade. I walk you through everything. Here's some of the equipment that you have. Here's your breadboard. You build these 2 circuits. Here's what you do to set up the equipment. I walk you through everything. And then it gets to the end of like where a deliverable is, and I highlight what you need to do, right? So it's like, take a short video showing the operation of your circuit. This video satisfies the requirements for deliverable number 1. So it should be very clear as you read through these what you actually need to turn in order to get graded for this circuit. And that's how the entire thing is. So if you scroll through these things, you're just going to see it's more and more of that. The circuits do get more complicated, but they get a lot funner too. So that's what the lab exercises look like. And then when you upload those, you actually come down here and you click on the assignment folder, and that'll actually give you a place where you can upload those assignments. Okay, that is it. So at this point, you watch the overview video. So if I come into content, I'm gonna watch the overview video. I've read the syllabus, watched the overview video, and now I'm ready to take the course overview quiz. How did I know that I needed to do that? It's because it was in the syllabus. After that, what do? It's like I start on module 1 because those deliverables are due on Wednesday the 12th. And where do I find those module 1s? Well, I go over here and I go to the next content page, module 1, and here's where I access everything, here's where I do everything. And then it's like, okay, am I done with the week? I go back to the syllabus, and it's like, I am. And that's how you do. So you're just going to repeat this over and over and over. And what we'll do is we'll put announcements every week that come out that kind of remind you that you're working on this stuff. But that is it. So good luck this summer. I look forward to working with you, and see ya.